I'm waiting for someone else to bring me the parts, and I'm just kind of observing, looking around, and look at how sketch this is. That is a drop ceiling. Look at all those heat lamps and buckets they have stacked on top of that ceiling tile grid. That whole thing's gonna, it already is like falling apart. That is pretty darn sketch, man.
This video is brought to you by Sporlan. Quality, integrity, and tradition.
Today's an interesting one. So I got a customer complaint that the glycol unit wasn't working. This is the draft beer system, okay? So they called out the draft beer technician, and it is now Tuesday, March 8th. Apparently they placed a service call last Thursday. The technician came out yesterday, and then they gave me a final diagnosis today and decided that I needed to come out. But what's interesting is they said the glycol temperature was like 60 degrees, okay? Well, it says 31 on the display. So when I pop my head up in here, I'm like, what? It says 31, why? So then I go over to the beer taps, and I poured a pitcher of Bud Light, or not a pitcher, but a cup, just to see, a glass, and it was like 44 degrees, okay? So this is odd because they were saying it was in the 60s. So I was making sure I was working on the right unit. I am. All right, so apparently, I remember that glycol unit. They replaced it with this thing that looks really high quality. And they left the old one up here like dum-dums they were. That's ridiculous, right? So also, this is the storage for the entire restaurant. So I'm going to start organizing and moving some stuff around. And what the heck is that? Some old school crap over there. So I'm going to start moving some stuff around, making some more space, because I do have another person with me. That way we can both work up here. So this is definitely not the highest quality looking unit, but hey, if it works, right? So their complaint from the beverage technician, I read their invoices, it said that the compressor was turning on and off every minute or so. What that means, I don't know. Compressor's running and it's warm. It's not abnormally warm. It looks like it's coming down to 29. Let's see what the set point is. Set for 28, so it's gonna cycle off. I suppose it's possible that that the starting components could be failing on the compressor. There's so many different things. The condenser does not look dirty, but we will investigate further. All right, before we got too far, we went ahead and went into the beer walk-in, which is right below us. The beer walk-in itself is at about 38 degrees. It just cycled on, and it is not iced up. So first and foremost, we checked that to make sure there was no issues there. So the beer walk-in is good. Now we are waiting for this guy to turn off. I don't want to play with anything. I just want to see it turn off and then turn back on and make sure that we're not getting this weird on and off like the beverage tech said. We want to try to see things before we put gauges or anything on it. We just want to observe. All right, we naturally cycled off at 28 degrees, okay? Condenser fan motor seems to be moving in the right direction. We opened the reservoir up. There's fluid in there. Now, there's no ice from what it looks like. Doesn't seem like there's any ice in there. Now, is the glycol actually moving? Because sometimes what can happen is you can have a bad pump when the motor's still running, and that can be an issue. So we do need to verify that the glycol is moving. Usually, you can see it moving around in there. I really don't see any turbulence, so I'm kind of suspect of the glycol, whether or not it's moving properly. All right, so lifting this up, we've confirmed that the pump actually is doing something. And I can stick my hand down there and feel it. So it is moving, it's just not very turbulent. So we're good on the pump. The pump is moving fluid properly. Everything's good. I will do a current test on it, but the beverage tech said the pump was fine. What I'm kind of guessing, before we go any further, is I'm guessing we're going to have some starting components that are failed, because I don't doubt that they saw it high in temp. And if we have a start capacitor that's going bad, it's possible that it might start every once in a while, but have a hard time sometimes too. So I'm suspecting that's what it's going to end up being, possibly. We'll see though. Usually if it was a refrigerant related problem, you would tend to see like a ball of ice around where the capillary tube hits the unit. So we'll lift it up real quick And let's see down in there. Usually you'll see like where the capillary tube meets. Yeah, you see there's no massive amount of ice or anything right there. If it was a low charge, typically you'll see something right there where it'll frost up or something. I'm not seeing an issue there. So yeah, this is interesting. All right, we're getting ready to turn this guy back on. So we have the pump running. Always turn on the pump first. We're going to turn on the power to this guy. We've got our amp clamp on what I believe to be the wire for the condenser itself. Let's turn it on. Wait for the startup of the control. And again, we want to see this thing restart. So it should be calling right now. It's at 32. I just heard it turn on. And it doesn't sound like the compressor's running. 0.39, that's just the condenser fan motor. Let's see if we can hear it. Is it off on overload? I don't hear it necessarily turning on and off on overload, but we need to get down in here and test the starting components and test the actual voltage at the compressor to see if it's correct. But yeah, compressor's clearly not running, so I'm hoping it's just starting components. And it just restarted now. 4 amps. And it's running. And it seems like it's running decent. So yeah, we need to get in there and test those starting components for sure. Alright, we took the side off the unit, and yeah, it's a little giant mess in there, a little thing. So we need to get in there and, oh, I think I can see it, actually. Let me turn this off. Can I see? Oh yeah. Yeah, it's gonna be a bad capacitor because it looks like there's fluid in there. It looks like it potentially leaked. Yeah, for sure. So what is that capacitor? 324 to 389. Boy, that is a tiny capacitor. And I can almost guarantee you that the TECEMSEH supply house is not going to have that. Now, the 3-in-1 is not going to be big enough to start this guy either. 324 to 389. That is a big ass capacitor. I will potentially have a temporary one, but we need to get in here and physically test this first. Let's go ahead and test this guy and see what it says. So we on, and it is slightly low, but not horrible. 320. Okay, but you can clearly see where something's, it looks like the oil's leaking out of this thing. So the question is, can I put a temporary start capacitor on here and test the other operations? Now the relay doesn't look like it's a problem. And it doesn't sound like it's a relay problem. The overload in here doesn't look bad. So yeah, we're gonna put a temporary start capacitor on here. Alright, so if you guys don't have it, there's an app for TECEMSEH compressors. I'm gonna look it up real quick. So it's a AEA4450. Oh, it's a AE. That's right. Old numbers were AEA. AE4450, and then it's a Y. This one right here. Find the right model number, right? There we go. And then go down and hit search, and it's going to give you all the OEM component part numbers from TECEMSEH Direct. So we called the supply house. The supply house local to us actually has all 3 of the OEM components. Now, this capacitor is technically not testing bad, but what's weird is the first time I tested it, before I got it on camera, it tested really low, okay? Now, that can also be an issue with your battery, because it is using a 9-volt battery, but my battery is pretty charged. It's 3/4 of the way, so I don't think that's a problem. And what's weird is the compressor's intermittently turning on and off. So we are going to try to change the starting components. Now, because of this 324 to 389, my universal start cap that I have doesn't go that high. And a 3-in-1 is not going to go that high either. So we are going to get the factory starting components. We're going to throw them on this thing and then test to see if we still continue to have the same issues. I don't like doing it this way. Normally, if I have a 3-in-1, I'll temporarily throw it on, or I'll use my universal start cap, but this is such a high number that it won't reach those numbers. So I'm waiting for someone else to bring me the parts, and I'm just kind of observing, looking around, and look at how sketch this is. That is a drop ceiling. Look at all those heat lamps and buckets they have stacked on top of that ceiling tile grid. that whole thing's gonna, it already is like falling apart. That is pretty darn sketch, man. All right, we have new starting components. Everything's a different size. The new capacitor comes with a new bracket, which is a must, but it doesn't come with the wires. And the old one had the wires connected on it, so that's going to be a thing we got to figure out. And you know, I don't have flag connectors, which is a pain. I really need to get some crimp on flag connectors, because making that 90-degree bend so the wires can come out is going to be tight. We'll have to see what we can do. I do have some extra wire up here. I brought some up, so this is kind of going to be a long, tedious process. Also on these starting components, they typically come with instructions in case you can't figure out schematics and different things. So all right, so this is what I come up with. We grab the non-insulated connectors and you bend them, and you can get them on there, and then we can exit out this side and they'll still fit under the cover and be able to be closed up. So sometimes you got to get creative when you don't have flag connector. Before I go too crazy, I pulled everything off and we got resistance values and we confirmed, okay? So like this, all right? So common start run, 4.18 for the start, 1.36, and then 5.38. If you go to the TECEMSEH app, they actually tell you, and we're pretty close. So start winding's 3.8, run winding 1.14. Now again, understand that that resistance is going to change with temperature, so the hotter or colder it is going to be a little bit different. So I don't see anything just crazy about this. We were close on the start winding. It says 3.8. I'm measuring 4.18. I mean, we're close, so we're going to continue putting the starting components on this guy. And then, you know, sometimes working on these little guys is actually harder than working on a giant compressor, because it's so tight in here trying to figure everything out and make sure everything's going to fit. We also do have this completely unplugged from the receptacle over there. So yeah, we're going to keep putting this guy together. All right, we think we did everything right, but it is rather tight in here. If I did everything right, I do have electrical connected for current and for voltage. There was 2 ground wires that I disconnected. I just temporarily put them together just for safety with an alligator clamp just pulled out of the way, so that way we are not missing a ground. I mean, I'm sure it would be grounded, but we still just be safe. So we've got a pump. Okay, pump's back on. Right, and waiting for the temp control to fire up. Let's watch the meter. Started a little rough. That's the condenser fan motor, the weird sound. So we've got 120 volts. We're running 5.7 amps. That is compressor and condenser fan motor. And this guy says 7.75 amps on the TECEMSEH app. That doesn't sound bad at all. Now, that condenser fan motor is certainly wobbling. What is the dealio with that? Yeah, I think it's just because I have all the panels taken off. It seems like stuff's in a weird bind. Now, another thing I'm going to say, so far we look good, but we're going to watch some cycles where it turns off and turns back on. So we're going to see the whole thing come down to temp. We'll watch current the entire time. Again, having the meter that can show you current and voltage at the same time is really nice. This is the Fieldpiece SC480 meter. I like this one because it's small and compact. Yeah, this capacitor, they gave you a new bracket, but the way that it was mounted on the old one, there's no way to mount this, so we're just gonna have to zip tie it. My most important thing about the capacitors though is that they come with the covers. I don't like aftermarket ones typically, because then they lose their NEMA rating, you know, and then someone can accidentally brush up against that. So I prefer them, whenever we replace them, we put on OEM caps so that way they have the covers. Now sometimes we'll do it temporarily to get them going, but so that vibrating, the condenser fan motor is kind of every once in a while making like a vibrating, like the blade is out of balance. Like there it goes. But when I think it's just because I have the side panel off and the unit's kind of losing its structural stability or whatever. Because when like it's doing it right now, right? But if I just put my hand behind it, it kind of stops. Yeah, it stops now. And it doesn't feel like the fan motor's got bearings going bad or anything. I just think that once I put the unit back together, I think it'll be fine. I believe that fan motor was running 0.38 amps. Does it give you any information on here? about the motor? No. No, it doesn't. I'll try to stick my nose around there and see what the current should be on that motor. I'm all for supporting economies. I'm all for, you know, finding things cheaper. I get the Amazon effect, all that stuff. But this unit, I'm sorry, is dumb. And it's from a foreign country, okay? A lot of our equipment is. It is what it is, right? But seriously, if you're gonna send this, or if people are gonna buy it in the United States, they gotta make it easy. All right, look at this, how they have this refrigerant charge rated. 134A, 0.772 pounds. Why would they do that to us? That is just dumb. Tell us in grams or tell us in ounces. Don't make us go do a bunch of complicated math to figure out what the proper charge is on this. That's just dumb. Now I realize it's just a multiplier, 16 ounces in a pound, you know, you gotta do, but it's just, come on. If they're gonna be bringing this stuff into the United States, it better be legible and easy. It's a hard enough time keeping up with all the technology and stuff that we have going on in this trade that we got to keep up with that kind of crap now too. Come on, guys, that's just dumb. Luckily, you know, we can ask the Google and we don't have to do things crazy, but I mean, that's just ridiculous, right? So Google has conversion things, 0.772 pounds converted, 12.352 ounces, but still, that is just so dumb. I just turned it off because we're going to try to restart it right now to see if we see any issues with it restarting. Whether or not we need to put service gauges on it, you know, you just need to kind of look at everything. The charge is so low, like small, like 7 ounces, that it's questionable. So we're using vitals. The compressor is hot, but we have a cool suction line and we have no frost where the capillary tube enters the evaporator. So that's a good sign. We did just shut it off. We're going to turn it back on and see what happens right now. See if it restarts or if they have any struggles. I'm not seeing any issues. It restarted, so that's a good sign, leading towards maybe it was starting components that caused our issue. Now our current is a little bit high because it just restarted, but it should drop down. But still, it's not higher than what it says. It said something like 7 amps RLA, so we're still under that. We're looking pretty good so far. So we're gonna watch this guy completely come down to temp and see if it has any more issues starting. But again, we don't want to turn it on and off instantaneously. You want to give it about a minute before restart. All right, using the Field Piece app, we pulled it up. I did go ahead and put it on because it was taking a little while to come down to temp. So we just used the job link probes. So refrigerant pressures, not knowing what the high side's at, that doesn't look bad. For 11 degree suction, that's about a 9 degree saturation temperature. That's pretty decent for what I'd expect for an R134A capillary tube system. Again, we don't have the whole picture because we don't have high side pressures, but it's not looking bad. I mean, it's just on a unit this small, it is going to take some time to come down to temperature. That's inevitable, but we're not seeing anything really bad here. Superheat's not accurate because I don't have a superheat clamp. I actually have it right here, and there's really no valid place to get superheat because they have the capillary tube ran with the suction line as like a subcooling method, right? It brings the condensing temperature down a little bit, so and makes the liquid temperature a little bit cooler as it's wrapped with the suction line for efficiency. So it also makes it difficult to get an actual superheat. And if you look, the capillary tube is actually ran right up to the compressor and it comes out right there. So I don't think we're going to be low on refrigerant, so we'll go ahead and take the suction port off. It's not a great idea, but the suction side's not as critical because we're going to lose, you know, not even an ounce, if even that. You're going to lose minute amount of vapor, so it's not that big of a deal. But the liquid, if we were to put on a liquid port, we definitely lose a significant amount of refrigerant. They certainly don't build these units to have quick pull down times. Again, don't see anything wrong, but we turned it off right now. It's almost down to temp. We're going to turn it on again to make sure we don't have any issues on the restart. Let's see. No, it shouldn't be set. Oh no, that's the wireless. It restarted just fine. Correct voltage, no issues. I think we're going to be pretty good, so we're going to start assembling this guy. We're still going to watch it come down. It's at 32 and it's set for 28. Yeah, set for 28, so we're going to watch it a little bit longer and actually see it satisfy, but I think we're going to be okay, and I think the starting components were our issue. Whether or not there's other things going on is hard to say. They just got to kind of hurry up and wait, see what happens. This is insane. So we're just kind of looking at what they have. These right here are gas line connectors, the quick connect ones. There's 4 right there, 5, 6. Now, granted, that's not the nice brand. I like the other brand. I don't do those, but I mean, these ones are better than nothing. But yeah, there's 6 of those unopened just sitting up in here. Like, it's just crazy all the stuff they have up in here. They got pans for days. I don't know if they've ever bought pans because they don't need to. Like, it's insane. Check this out. Look at this. This is a roof drain vent. Or this is a roof drain. I can see it going up over there. Goes straight up. It comes over, and then I'm like, hey, why is this connector broken right there? And right there, it's being held up by those. I tried to lift it. That thing is full of sand. We're out in the desert where they have sandy conditions, and that's the roof drains. They always get plugged up. It's literally full of sand. Like, and the only thing holding it up is those racks. I don't think they meant that to happen either. That's just nuts. Like, the amount of stuff they have. I don't know what the heck that is. KitchenAid commercial, some kind of a kitchen appliance. But yeah, this is just nuts. All the stuff they have up in here and all the wasted money. Like, seriously, a bunch of those gas lines. I bet you those are a couple $100 each, probably. Like, it's just nuts. This guy really dragging butt to come down to temp, but I don't see any big issues, so we're gonna go ahead and start taking all our stuff down. We got all of our junk down for now, cleaned up a little trash that wasn't ours. I can't take that unit down because that should have been done when they installed this unit, because you probably have to pull the ceiling grid apart to get it down. But it's just nuts that, you know, when they did the install of this, they should have scheduled to take that down. You don't just leave it sitting on top of the walk-in. This walk-in's not made for this much weight on top of it. So I just came in the beer walk-in. It's pretty cold in here. It's actually in defrost at the moment. There's a Key to Therm Temp Plus defrost controller. But we did get back behind it. There's no ice. It's, like I said, it was down to like 38 or whatever earlier. Let's see what it's at right now. Looks like it's right at 40 because of the defrost. So that's pretty typical. But okay, we're just still waiting for that thing to satisfy. All right, so it's at 29 degrees. It's about to satisfy at 28. Look at this sketchiness right here. Someone grabbing that, going up on the walk-in box. We went and temped. We poured the cheapest piss beer they had, which was Bud Light. It temped at 41 degrees, which is pretty good. Give it a few more minutes, I told them. Now, one of the tricks, if you have warm beer and you just fix the glycol unit, what you can actually do, I would take you in there, but I can't really show the bar. But what you can actually do is clear the warm beer from the beer lines, because the beer walk-in's cold, right? The beer's cold in there, but then it goes into the beer lines and it gets warm when it's running in the attic and whatnot. So if you just go do like 2 pitchers of each tap head and dump it, if the manager's cool with that, they can serve beer faster because it'll clear out the warm beer. So that's a trick if you ever need to get, you know, beer flowing again, is just run the warm stuff out. Or you can just wait. It's just going to take some time. But yeah, this is good. We're going to go ahead and, I don't know what caused the starting components to fail. It was like an intermittent failure because there really wasn't fluid on the capacitor. Who knows? But we changed those and we have no more short cycling on-off overload situations. So we just tell them to keep an eye on it. I strongly feel like this unit seems to be undersized for what it's doing, but you know, I didn't design it, I didn't install it. I'm just here to make sure it works, and it seems like it's doing what it needs to do. So we're gonna give them the keys and we're done with this one.
So the beverage system side of things, the glycol units, the draft beer systems, I mean, those are pretty important in the restaurants, okay? It's actually one of the most profitable items is alcohol sales. So, you know, keeping the beer from foaming and having to throw beer down the drain, because that's what happens when you have warm beer lines, is they get a lot of head on the beer, and they end up having to waste a lot of beer to get a decent beer that they can sell. So it just becomes very, you know, expensive for them. So we got to make sure that that beer stays cold from point A to point B. So we have a beer walk-in where we store the kegs, and the transport line in between, whether it goes underground or into the ceiling, has to be insulated and cooled, and that's where the power pack or glycol unit comes in, because it wraps the beer lines and keeps them cool from point A to point B. Now, you can make glycol units too cold. There's a couple different ways. Basically we run it below freezing, right? We run it at 28 degrees, so they do have to use a type of antifreeze. Now they use propylene glycol, which is food grade glycol. It's not the same stuff that you put in your car. What you put in your car typically is ethylene glycol. That is deadly if consumed. Propylene glycol isn't going to be great for you, but you know, certainly you're not going to instantly die. You know, I mean, you're not going to die from it, but ethylene glycol can be very toxic and cause some serious problems. Same thing, like why they don't want you, when you're, you know, walking your dog around the neighborhood, you don't want them to lick up a puddle of ethylene glycol, because that can make them very sick, right? So anyways, maintaining these glycol units, it's a matter of making sure that the glycol concentration is correct. We don't just pour straight glycol in there, because if you poured straight glycol into the unit, then the pumps might overload themselves from trying to pump really thick glycol. So we do dilute it down with water, and we'll use oftentimes a refractometer to make sure that the concentration is right. So you want to make sure that your freeze point is, nowhere near what the system's going to get to. And the freeze point basically is the amount of water content in the glycol mixture, because if there's too much water content, then your freeze point's going to be too high, and then as you're trying to bring the system down to temperature, you might cause an issue. Something to think about is your evaporator TD. Okay, how cold is the refrigeration lines or the evaporator going to get versus the actual return temperature of the glycol? Because that temperature controller is reading the bath temperature. The temperature, basically it's the return air temperature. Okay, so it's the return glycol temperature. Your evaporator is going to get much colder. So you have to make sure, depending on how the manufacturer designed the equipment, that you don't want the freeze point of the glycol to be anywhere near what the actual evaporator temperature is going to be. Okay, so it's not a matter of just looking at what you're going to maintain the glycol at, 28 degrees in this case. So, in a perfect world, if we weren't concerned about the evaporator, we could get the glycol temperature down to 20 degrees, the freeze point, for safety, right? But because we have an evaporator that oftentimes can be 20 degrees colder or have a 20-degree TD on it, right? The difference between the glycol temperature in the bath and the actual saturation temperature of the refrigerant, you want to make sure that your freeze point is nowhere near that saturation temperature, or what you'll start to see is ice forming around the copper lines in the evaporator. And then once the ice forms, it'll actually act as an insulator and then just continue to build. Okay, so ice freezes at 32 degrees, right, with normal fluid, right? So, if we have ice starting to form around the evaporator and it gets thick enough, then it's actually going to bring the temperature of that bath up, because it's not going to be able to cool the bath anymore, and the ice is going to act as an insulator. So you got to be careful and understand where to set your freeze point, so that way you don't run into those kind of issues, okay? Now, on this intermittent problems like this is interesting. So I walked up and I listened. You're always using your senses. That's the important thing. So when I walked up, before I turned the camera on, I thought I heard the compressor turn off on overload. Okay, I did, but I didn't get to view it again. So that's why in the video, I was like, is that thing off on overload? I didn't know. It doesn't seem like it was, but what was odd was it wasn't starting. Okay. I investigated the start capacitor, and usually that's pretty suspect, and it looked kind of funky in the top, but further investigation, it really wasn't fluid. I think it was just a really cruddy design, the way that it was put together. But regardless, we know that we saw it not starting, and that's why I tried to restart it so many times after I changed the starting components. I probably did it another 3 times that you guys didn't see. I wanted to make sure that it wasn't going to go through this weird situation again, okay? It's always possible that there was an issue in the overload. It's hard to say. I don't think there was an issue in the relay, but it's possible that there could have been, okay? Whenever I change starting components, I change them as a set. So I change all 3 at the same time. The start capacitor, the relay, usually a current sensing relay, and then in the case of this one, it was a current relay, and then the overload, okay? Sometimes there might be a run cap in there. If there's a run cap, you'll typically see potential relays is what I tend to see on those. But anyways, we got them up and running. It's now been about a week since I filmed this. We haven't had any more complaints from the customer. Really important though, before you go down a rabbit hole diving into a glycol unit, always check your beer walk-in first to make sure that your problem isn't the beer walk-in. There's nothing worse than chasing a ghost in a glycol unit to find out it's working fine and your beer walk-in's at 50 degrees, That's going to cause some issues too. Another thing to think about, I always investigate and ask the manager. And there's these things in my head that I think up and I don't even remember to tell in the video. Whenever I go to a manager and they say my glycol unit's not working, I'll ask them, is it all your beers or is it just 1 or 2 of your beers? Okay. If they tell you, they have 12 different tap heads, right? 12 different types of beers, whatever. And if they say, well, it's only 2 beers, Majority of the time, the problem is not going to be a refrigeration problem. Now, if it's all the beers that are temping warm or foaming, then yeah, you're going to go down the refrigeration path. But if they tell you that it's just one beer, well, then they probably need to get the beverage company to come out and adjust the delivery settings, right, of the CO2 or the nitrogen or whatever they're using to push that beer through the lines. There's probably something going on there. So always ask questions, and it really helps you to understand what's going on. And in the same effect, ask to see other people's invoices, right? So in this situation, I said, hey, can I see the beverage company's invoice? Because I'm listening to what the manager is telling me, and he may not have said something right. So I like to read their invoices, read their descriptions, just to get a better understanding of what I'm up against, okay? It's just about slowing down, stepping back, and looking at the big picture. That's what I try to do as much as possible to try to eliminate callbacks and eliminate return visits and things like that. Okay. My calls, I stayed on site to watch this thing come down to temp. Now, had this been closer to my shop, this location is about an hour and a half away from my shop out in the middle of, it's far. Okay. It's way out in the desert. And they do have supply houses down there, and I was very surprised they actually had the parts that we needed, because normally I have to drive back to the Inland Empire where I'm from to get most of the parts that I need, which is a pain in the butt, okay? So that's why getting as much information as possible. But always take your time. Now, in this situation, because it was so far out there, I watched this thing come completely down to temp. If I was closer to home, I probably would have just said, hey, keep an eye on it. I'll call tomorrow to follow up, kind of thing. But I didn't want to have a return visit an hour and a half away from my shop. That's just kind of silly. So I take my time, try to do it right. Even though I got other service calls, I focus on the one service call I'm on and then move on to the next, okay? I really appreciate you guys making it to the end of the video. Keep in mind, if you haven't already, check out my website, hvacrvideos.com. We have merchandise available on there, helps to support the channel. There's a bunch of different ways to support the channel. The easiest way is simply watch the videos from beginning to end. It doesn't cost you a single thing. Just don't skip through anything. And then, it helps out the channel significantly. There's other ways if you want to donate via PayPal, Patreon, YouTube channel memberships. There's links in the show notes of the video. You're free to do so. If you don't want to donate, it's okay. It's not a big deal. I've been getting people commenting why would you ask me? I'm not asking you to donate. I'm just saying if you're interested and you feel free to do so, okay? But you don't have to. I'm going to keep making these videos. It is what it is, okay? Thank you so very much. Remember, I try to go live Monday evenings about 5 p.m. Pacific on YouTube. Also go live on the HVAC Overtime YouTube channel on Friday evenings about 6:05 p.m. Pacific with my friends. So definitely come check that out. I will catch you on the next one, okay?